Hello students, Namaskar. In our previous video, we found the inverse of a square matrix of order 2 by using a series of row elementary operations or transformations. Here we will be finding the inverse of the same square matrix of order 2 by using a series of column elementary operations or transformations. So students, remember I told you there are two methods of finding the inverse of a square matrix using elementary operations or transformation. The first method is you can either use what? Row elementary operations, and the second method is you can use the column elementary operations or transformations. So here we used the row elementary operations and we found the inverse of the square matrix. Now we'll be using the column or elementary operations and we'll be finding the inverse of this particular square matrix. So students, we got the inverse of this particular square matrix as this. Okay, now by using column elementary operations, a series of column elementary operations or transformations, we are going to find the inverse of this particular square matrix. So remember students, I told you when we have to use a series of column elementary operations or transformation, we have to write A as A is equal to AI. Okay, now we'll be writing the value of A. The value of A is 1, 2, minus 1, 3, and that is equal to A times the identity matrix as 1, 0, 0, 1, because when we use the column elementary operations, then we can use on this and this particular matrix. This has been told to you. So let us start students. What is our objective now? Our objective is to make this as an identity matrix of order 2. So let us start students. How can we make this as an identity matrix? These two elements must be equal to 0 and these two elements must be equal to what? 1. So let us start students. If I use C2 plus C1, then this particular element will become 0 students. You may notice this particular element will become 0. So here applying this particular, you can write here applying this operation on this one. So when we apply this operation on this one, we get, since the operation is on C2, so C1 as it is 1, 2, and C2 will be changed. How? C2 will be replaced by what? The C2 will be replaced by C2 plus C1. So C2 plus C1, minus 1 plus 1 is equal to 0 and 3 plus 2 is equal to 5 is what we have got. So this side as well will be using the same C1 as it is, and this plus this is equal to 1 and this plus this is equal to 1 is what we have got. Now students, what we have to do to make this as an identity matrix, what else is required is we can multiply this C2 by 1 upon 5. So this C2 being replaced by 1 upon 5 times C2. When we do that, we get the matrix as 1, 2, 1, 2, and this side we get 0, because 0 multiplied by 1 upon 5 is equal to 0, and this multiplied by 1 upon 5 is equal to 1. Okay, and is equal to A times, and this side what is there? C1 has to be written as it is 1, 0, and C2 to be multiplied by 1 upon 5. So the elements are 1 upon 5 and 1 upon 5. Now only one thing students, if we make this as 0, this particular matrix will become as an identity matrix. So this, now what to apply? We can apply that C2, or you can say C1, to be replaced by C1 minus twice of C2. this is one of the column elementary operations, or you can say third column elementary operations. So when we apply this, so see 1 minus twice of this one is equal to 1 only, 2 minus twice of this one is equal to 0, and these same 0 1. The same to be applied this side as well. So see on C1, this minus twice of this one, so 1 minus twice of this one is equal to 1 upon 5 students. Okay, 1 minus twice of, sorry, it is 1 minus twice of 1 upon 5, so we'll be getting here 3 upon 5. This is 3 upon 5. Okay, and this minus twice of this one is equal to minus 2 upon 5. Okay, and these elements will be of C2, 1 upon 5 and 1 upon 5 as it is we have got. So students, what do you notice? An identity matrix is equal to A times some matrix. So we can say here we have got I is equal to A times A inverse. If this is so, that means A times A inverse only is equal to identity matrix. You can write, we know that I is equal to A times A inverse. So I is equal to A times A inverse. So what is A inverse? A inverse is equal to what is this particular matrix? So this matrix can be written as A inverse is equal to, this is 3 upon 5, 1 upon 5, minus 2 upon 5 and 1 upon 5. That's how we have got the inverse of this particular square matrix using a series of column elementary operations. So I have told you both the methods of finding the inverse of a square matrix using elementary operations or transformation. So जब भी आपको ऐसा क्वेश्चन दिया हुआ हो स्टूडेंट्स, तो पहले आपको डिसाइड करना है कि मुझे रो एलिमेंट्री ऑपरेशंस यूज़ करने हैं या कॉलम एलिमेंट्री ऑपरेशंस यूज़ करने हैं. अगर आपने डिसाइड कर लिया कि मुझे रो एलिमेंट्री ऑपरेशंस यूज़ करने हैं, तो आपको कंटिन्यूसली रो एलिमेंट्री ऑपरेशंस ही यूज़ करते हुए इस साइड की ए को आइडेंटिटी मैट्रिक्स बनाना है. और अगर आपने डिसाइड कर लिया कॉलम एलिमेंट्री ऑपरेशंस यूज़ करने हैं, तो आप ए को क्या लिखोगे, ए इज इक्वल टू ए आई. और रो एलिमेंट्री ऑपरेशंस अगर आपको अप्लाई करने हैं, तो ए को ए इज इक्वल टू आई ए लिखना है एंड ऑपरेशंस टू बी अप्लाइड ऑन दीज. ठीक है, ये ध्यान रखना है. और फिर एलिमेंट्री ऑपरेशंस अप्लाई करके आपको ए इनवर्स फाइंड कर लेना है. आई होप यू हैव अंडरस्टूड बोथ ऑफ द मेथड्स. थैंक यू.